Welcome back to the 1600 game. We're going to look at some math questions here today. I'm with Yan Saraphimov, and he's one of our great tutors. We're going to look through some questions in practice test 4. So let's get started. What's the first question you want to look at?
I was looking at question number 8.
Nice.
Module 2.
Cool. Well, read it for us, and then we'll talk through it.
Yeah, so it gives you the function h of x equals x squared minus 3. Then it says which table gives 3 values of x and their corresponding values of h of x for the given function h.
Cool. All right. So we got multiple choice answers. The answers are in terms of these tables here. So what do you notice about this question that you think is interesting from a student's perspective?
Well, the first thing I noticed is that the x values are the same for all 4 options.
Yeah, good.
So probably the most logical thing to do would just to plug in the first value of x.
Totally. We plug in the value of x and we just tell. Now, here's something that you might want to pay attention to. If we look at, this set of, like, they all overlap in some way, right?
Yeah.
But in my experience, the fastest way to get started with these, it doesn't always work, but you want to be a contrarian on the SAT, all right? So you got to think about what is everybody doing, and then you want to do the opposite, which, comes naturally to some of us. But let's go to the value on the far right-hand side, all right? X equals 3. You could easily say x equals 1 is convenient. As a student of the test, we would say that the likelihood is, on a hard question, the one on the left-hand side is going to work out for multiple answers. The one on the right may not. We'll see if I eat my words on that. But so if we put in x equals 3, I'll write, but you talk here. So if I say h of 3, do the math for me here. I'm going to square 3.
9.
And then subtract 3.
6.
Yeah. Okay. So look, actually, we're done. Oh, we're not done.
Yeah, there's 2 options.
Okay, fine. There's 2 options. We got A and B. Cool. All right. So now, obviously, maybe we should do what you suggested, shouldn't we?
Yeah, because if you look at one, actually, h of x is different for each selection.
Yes.
So if you start.
Well,
from
B
one,
and D, right? B and D are the same for one,
yeah.
the same way
Yeah,
that A and B are. But it turns out we have to look at 2 numbers in this case, right? And if we put in 1, do the math for me again. So h of 1, we're going to square 1, and then we're going to subtract 3.
minus 2.
Yeah, good. Awesome. So you can see actually that if we look back at the other answer choices, literally every other answer of the 3 incorrect answers, A, C, and D, they all share a common value with the correct answer, right?
And you would want to avoid choosing 2 as your plug-in value because 3 of them are the same.
Yes, exactly. Yeah, so we want to be thoughtful about like the numbers we're picking, and the further we get into the test, the more that being a contrarian is going to be helpful.
Yeah.
Great. Awesome. So this is module 2, and we know that the questions get harder as they go, and that we're into the stuff that kind of makes the difference between getting a 600 and a 700, or a 700 and a 750, or dare we even say 800. What's the next question you want to look at?
It's the next one, number 9.
Cool. All right. So read this off for us.
The function f is defined by f of x equals 270 times 0.1 to the x. What is the value of f of 0?
Yeah, and this is one where if you know it, you know it, and if you don't, you don't.
Yeah.
Right? I mean, you could use your calculator. It's a kind of a little bit of a waste of time for some people, but tell me about the ways in which you've seen students make mistakes on a question like this.
Well, I could see how you could think it's C because you're like something to the zeros itself. So 270 times 0.1 would give you C.
Yes. Yeah, that's a reasonable confusion, right? Like, because anything to the power of 0 is what?
1.
Yeah, exactly. So it is 1, but it's easy to think it's like 1 times itself.
Yeah.
So one way that I show people, because like what happens for students is they know some things from math class that they haven't thoroughly examined, right? And this might be one of them, like that raising something to the power of 0 is 1. And depending on the kid that we're working with, sometimes we really want to have, that deeper understanding. We have the time to do it, and we want to make sure that these kids really like have flexible knowledge. Like we were talking about before, if somebody can check their work in a different way than they've done it originally, then they've actually checked their work.
Yeah.
Right. So I don't know. Do you have any ways that you would think about proving to somebody that anything to the power of 0 is 1? I use like ratios for this.
I would do the ratios thing too.
Yeah, yeah. So what if we said something like, this would be a good way of doing it. We'll do something really easy with numbers that kids feel comfortable with. Let's just prove that things raised to the power of 0 equal 1 by saying like 2 cubed, right, over 2 cubed, right? Because most kids that we work with know, what can you do when you divide and you've got the same base? What can you do with the exponents?
You can subtract them.
Exactly, right? So we could say 2 cubed divided by 2 cubed. If we did it in the fancy way, we would say that's, subtract the exponents. 3 minus 3 is 0. And sometimes what I'll do is I'll write in the reverse direction. I don't know about you as a sort of a more trained math guy, how you feel about this move, but I would like put an equal sign to the left of my original, ratio. And I would say just that's 8 over 8, right? Because 2 cubed is just 8.
Yeah, that's fine.
Yeah, cool. And then so to the left, I've got a 1, and to the right, I've got 2 to the 0.
It's not the most formal proof.
Okay, yes, you'll forgive me.
Doesn't matter for the SAT.
Yes, cool. So. Good. All right, so we've proven that anything to the power of 0 is 1. So, of course, what is the right answer to number 9?
D.
Yeah, good. And we could see that A and B represent other traps.
I could see how B could be, because you could think X is like raising the whole thing to the power of 0.
Totally. Yes.
So like, oh, it's all just 1.
Yes. Or you just like forget what you're doing, on a more complicated word problem, that's more likely that you just do the pertinent thing, raise it to the power of 0 and think you're done, right?
Yeah.
And of course, a lot of people just think anything to the power of 0 is 0.
Yeah.
Right? Because we confuse what happens with multiplication and exponents. So cool. All right. So that's a good one. We've covered a couple questions here. What's the next one you want to talk about?
Number 12.
Okay, cool. All right, so number 12, read this off for us.
So it gives you the quadratic negative 4x squared minus 7x equals negative 36. And then it asks you, what is the positive solution to the given equation?
Yes. So this is one where I really don't mind if people just go nuts with Desmos.
Yeah.
That's perfectly cool. You just throw that.
I keep forgetting they have Desmos now.
Yeah, and it's an amazing tool. A couple of years ago, that wasn't the case, but you've got Desmos, you can just go to town on that, right? So that is reasonable. I wonder if we can imagine what kind of input errors, like this, just literally typing, how people could make a mistake just putting that into Desmos.
Well, first you have to set one side equal to 0.
Exactly.
So maybe they forget to do that step.
Totally. Yeah, that would be a very easy mistake. And even if you know to do that, right? If you know to, I'm going to pull up Desmos here. Even if you know to do that, you could easily make a mistake with the sign, right?
Yeah.
Can you read it off to me again, the original function as it was written?
Negative 4x squared minus 7x equals negative 36.
Yeah, negative 4x squared. You said minus 7x? Cool. Minus 7x equals negative 36?
Yeah.
Cool. Okay. So when you put it into Desmos, you literally get these two values and you're basically done. Okay. So that would be a question where the Desmos bros have the move. That is like the best way of doing it. It's also the case, though, that when we're preparing for this test, that like we use every question in which we have like a method. We don't just stop there, because there may be questions, and people can take our word for it here. We'll see other questions later that do this, where Desmos is insufficient. You can't just type it in and get the answer.
Yeah. Okay.
So let's kind of talk through how we would solve this one without Desmos. Okay. So I'll write, but you tell me the moves. Dictate to me. I'll be your scribe.
Well, there's two ways you can approach it. Either like just knowing the quadratic formula or factoring.
Yeah, cool. Let's try factoring. So what do you think you want to do? Do you want to move the stuff to the left or to the right?
To the left. Okay. So you want your right side to be 0.
Yeah, right side's going to be 0. So negative 4x squared minus 7x, and then what? Plus 36.
Plus 36.
Right. Cool. All right. Cool. So we've got that. Now, let's just admit that it's kind of annoying and hard to like deal with the factoring with this current situation, right? So this would be a good example of like someone who didn't utilize their tools correctly would be, wasting time if they didn't know to use Desmos here.
Yeah.
Right? But factoring is a super crucial skill. So let's walk through how to factor this question here.
Okay.
Right.
And then your x squared term is negative, so I would divide by -1.
I love it. So 4x squared plus 7x minus 36 equals 0. Okay, and I'll set up my couple of parentheses here. And then tell me how you think about something like this, because the 4 makes it, the coefficient in front of the x squared term makes it harder.
A lot more harder.
Yeah.
So
this might be an example of one in which the answer choices might be of value to us.
Yeah, I was going to say like C and D are probably not the answer.
Yeah.
Because they stem directly from like the -4 and the -7.
Very good. Right.
So
the high likelihood is we're talking about either A or B.
Yeah.
Yeah. That's great. That's a great starting place. And then there's also, if we're really savvy, something worth noticing about the denominator in A and B.
Oh, right. So from that, you can assume one of your factors would have 4x.
Yes. So let's bring along the people who are like, what the heck are these guys talking about? Like, how do we know that? Well, maybe we'll answer that question, with some hindsight. We'll keep working. Let's just, if you're with us, you're with us. If you're a little confused about why, you will be with us soon enough. Just wait for us and we'll get there. So I'm going to put a 4x and an x. We know that that's the case now based on our reasoning, right? So tell me what else we know based on the standard form that we have, 4x squared plus 7x minus 36. What else do I know about the factoring?
Well, just from the principle of factoring, you need to find two numbers that multiply to A times C in this case, because A is not 1.
Yes. Yeah, so we need to find two numbers. Sometimes what I'll tell people is to pay attention to the signs first and foremost, right? So the fact that we have a -36 and a +7, right? That the C term is a negative and the B term is a positive. We know what do we need for signs in the two factors?
Also positive and negative.
Exactly. We know we need a positive and negative, right? And again, from the answer choices, I can kind of infer that if we're using these dividing by 4 and A and B, that I'm going to put the negative sign with the 4x.
Right. Yeah.
And the positive sign with the x. Right? Okay, cool. And then now it's kind of a little bit of a guessing game between A and B, but it might not be that hard of a guessing game. I'm not sure.
Well, first you need to multiply 4 times -36.
Yep, so 4 times -36 is going to be -144.
Right.
Okay.
And then from A and B, you can guess one of your negatives.
Yeah, good. So which one you want to try?
We can try 7 first.
Yeah, okay, cool. So we're going to put a 7 with the 4x, right? And then we would need something that gets us to 144.
Which I don't think it does.
Doesn't.
So you have to go to 9.
Yeah, beautiful. And the 9 would imply what about the other factor? It would be x plus what? In order to get 36.
We have to multiply it to -144.
Yes. Okay, cool.
If we have -9, it would be +16.
Yes. And so, +16, but then is it divided by 4? Is that correct?
Well, then you have to group them to get like it's a lot more complicated when A is not 1.
Yes, it is. I think.
But you already have the -9.
Yes.
So you can stop here.
You could stop right here
and
say you're done. Right. So there we have it. B. If you wanted to follow through, you could say things like, well, the term -9 and the other term in your factor, I think, have to multiply to be -36. Right. So I think, therefore, I could put a 4 in there based on that, right?
That's right. Yeah.
So sometimes what I'll do for people, I tell people divide and conquer with this kind of more complicated mathematical. I don't mean like the operation divide as in the opposite of multiplication. I mean to say to yourself, like, okay, the answer choices have told me that I need a 4x, right? The signs have told me that I need a positive and a negative. The answer choices have implied where they go.
Yeah.
And then just thinking about the last term of negative 36, I knew that it had to be, if we were using 9, we're going to have to use 4, right? So we could then expand that back out to C, right? So this kind of, in a certain way, what we've shown probably most saliently for students is why Desmos is your best friend on this question, right?
Yeah, Desmos makes it a lot. You would save a lot of time on this question.
Yes. Yes. So by foiling, first term would get you 4x squared. Last term would be 16x. The inside term is negative 9x. I misspoke. I said it's the first term's 4x squared. Outside term is 16x. Inside term, negative 9x. Last term is negative 36.
Yeah.
And that does simplify the way we want it, right? You want to be able to factor like that, but also you got to pick your battles, and definitely Desmos is your best friend on this question.
I would say if you did it like the old school factoring method, you would lose too much time.
Totally. Yeah. So I have this phrase that, you've heard me say before. I love the idea of test awareness. And by that, I mean, like, know where you are. Okay. So if you're crushing SAT math, this says number 12 on our PDF version, but on the real test on module 2, this is going to occur at like 5 in module 2. And so you have to know that your tools like Desmos are probably sufficient here, but that if you get to number 21 and you're asked to do this work, to just make sure that you bring your reasoning with you to the table and you don't just stop at, inputting the values into your calculator.
Yeah.
Right? Cool.
And then if you're really scared, you can plug it back in to make sure it works.
Totally. Yeah, which is a great move. Yeah. Okay, cool. So we've got it. After 12, what's the next one you want to do?
Number 15. Word problem.
Word problem. Yeah, these are the ones that scare the heck out of people. All right. So I won't make you read the whole thing. We'll go in a piecewise manner through this question. So read the last sentence for me.
Based on these data, how many people voted against the proposal?
Yes, a little implicit grammar lesson in there with the data for some people, myself included. So we know that they're asking this very particular thing, which is how many people voted against the proposal. Okay. And what I tell students all the time is when you have a word problem, almost every sentence is going to do something for you. Just assume that every sentence is of value for now. And when you read a sentence, take action, right?
Yeah.
Take immediate action. Okay. So
start writing.
Yes. Do something, write something down, right? Active measures, right? So there we have it. I've underlined the word against because I don't want to lose track of that. It's probably the case that who voted for is going to be part of our calculation, and we could easily forget which one of those two things we care about primarily.
Right.
Okay, cool. So now what we'll do is we'll read each of the sentences. And right after I said every sentence matters, I don't know how much sentence 1 matters. I'll read that and then I'll let you do the useful part. A proposal for a new library was included on election ballot. Cool information.
Yeah, don't have to write.
Yeah, we could leave that one up. But we probably will write something in the next sentence. You can read and I'll write something.
A radio show stated that 3 times as many people voted in favor of the proposal as people who voted against it.
Yeah, so I'll write something like favor 3x, and I'll just write AG for against because I'm trying to move fast. I'm on a test here, and I'm just going to write X. Right. So that was my way of just like putting it down. And what I didn't do is build an equation. Okay. I urge every student, do not build an equation here, because if you do, you're likely to like have built some assumption that has some probability of being incorrect. Right.
Yeah.
So I use arrows. It takes the pressure off. It's just like favor goes with 3x. Against goes with X. Right?
Yeah.
Cool. All right. And then read the last sentence that we have to read, the second to last sentence in the paragraph.
A social media post reported that 15,000 more people voted in favor of the proposal than voted against it.
So, okay, because you brought this question to my attention, that the heart of the challenge is right there, right? That language can be easily misconstrued.
Yeah.
So you take us in any direction you want with how to think about working through this problem or what you've noticed, based on that.
Well, my engineering brain just jumped to like, oh, this is a systems of equations.
Perfect. I love it.
So I assigned each value a variable. So for me, the pros were P and against was A.
I love it. Yeah. And
then from that sentence, the difference between them is 15,000.
Yes. Very good. The difference between them. So I might say what, like P minus A?
Yeah.
Yes. Equals 15,000.
Yeah.
Yeah. That's great. I love how you called it your engineering brain.
Yeah.
Would that we all had engineering brains for moments like this?
Yeah, I feel like you could mess up that setup in a lot of ways.
Yes, totally. Yes.
Because you have to recognize it's a difference, not
totally
an absolute more than a baseline.
Yes. And building equations, okay, I will tell you, I used to be militantly against building equations in moments like this. But the test has changed over time, right? So 18 years ago, I was like, just never build an equation in this moment. And at a certain point, I had to adjust my thinking and just recognize that, you should probably be able to build equations if you want to get an 800 on the SAT. Okay.
Yeah.
But let me show you how we could do it without building an equation.
Okay.
So you noticed something on the last question that I loved, which is you said that the answer choices that were numbers from the problem were likely untrue, likely not the right answer. Right.
So you could get rid of B.
Yeah. I'm at least going to start by saying B is
not get rid of, but probably not B.
It's unlikely to be the correct answer. Right. Okay. So if we then say that there are three, more probable answers, A, C, and D, right? Then what we can say is, well, we could try them out. And we could also use our faculties of reason to limit the amount that we have to try out. Right. So for instance, let's take C as the middle answer. Without thinking too hard on the test about where you should go and when, without trying to be too cute, it is useful to say the right approach is go to one of the middle numbers, because you might be able to figure out that you need to be bigger or smaller, right? So if you're lucky, of these three answers, you're right. And if you're unlucky, you've sort of created your own luck at a different level. You might be able to say, okay, it's got to be bigger, it's got to be smaller. I don't know if that's the case here. I haven't thought that far into it, but I'm just going to go with C to begin with. So let's talk about it this way. This is the people that are against. We've underlined that word in all of our thinking. We haven't forgotten that. If 3 times as many people voted in favor of this, then I could get a number for that, right?
Yeah.
And, people could go to their calculators, but you and I can figure this out.
60, it's roughly 66.
Yep, 66 and change, right? 67.5.
Yeah.
67,500. And I love that you said roughly, because actually that's sufficient. I think the reason you said roughly is you had already figured out that that's wrong based on the rough calculation. So explain that for folks who are watching.
Well, because the second to last sentence, 15,000 more people voted. Yeah. 66-ish.
Yeah.
Again, minus 22,500 is definitely more than 15,000.
Yeah, it's wildly wrong.
Yeah.
Right? And then we can just say that for sure D is wrong. Right?
Yeah.
Because we're going to get bigger. 45 times 3 is going to get bigger. And that's, the problem is only going to get worse. Right? The discrepancy between 3 times as big and 15,000 bigger. Right? So, no, I would not say just assume, that A is right. Although if you're running out of time on this test and you're this is actually a probably high probability guess at this point.
Yeah.
Right. And of course we could do that, 7,500 times 3 is, lo and behold, it's actually
C.
Yeah. Right. It's actually answer choice C. It's 22,500. And then, of course, we can see that the difference between those is indeed 15,000.
Yeah.
Right? Okay, so like I said, when I was first getting started with this, that kind of a move is different than people do the question. And so it's valuable for students, and we can totally fall in love with like methods like that.
Yeah.
You know, we could give it a fancy name. We could call it back solving, working backwards from the answers.
Brute force.
Yes, yes, brute force is just as fancy an answer for, or a method title for this. But I think both. You want to have both, right? So
Yeah.
if you build the equation that you did, you had P minus A is 15,000. Let's talk about the other equation that you would have in that system. P minus A is 15,000. That is the pro voters minus the against voters, 15,000. What would be the other equation?
Well, then you need your 3 times relation.
Yes.
So you would have the pro equals 3 times the against. So P equals 3A.
Yeah, and that would be a nice equation because then you could just substitute.
Yeah, it's very simple.
Yes, 3A minus A is 15,000, and then you could easily make your move. Right?
I mean, I think it's just knowing what you're good at.
Yes.
Like if you're not comfortable setting up systems, try to avoid going that route. But if you are,
if you are, just go
for it.
Right. I will say something you said in our last meeting that I think for the confident students is super important. And what we hope is that the more people work with us, the more confident they get. Right?
Yeah.
But, I'm going to use a fancy phrase, epistemic humility. Okay. Like the humility of like, how do I know what I know? Right. People who are taking IB classes, they get this class called theory of knowledge. And I hate that name because it's really just called epistemology. How do you know things? Right. So epistemic humility would be like, okay, I built this equation. I feel pretty good about it, right? But if you've built the equation, like you said, one of the things that just let me know you're a great teacher is you said, well, if I'm checking my work, I want to see if I can do it differently. The students who build the equation here, they'll very quickly get their answer of 7,500, hopefully. Or else maybe they got C, right? That is.
Yeah, if you switch that, if you switched your ratio, which I've done a lot as an engineer, you could write 3P equals A because you're like, oh, totally. 3 times.
Yes.
I don't know. It's easy to get backwards.
Yeah, and the reason why actually is a fact about the way we write sentences versus the way the equation gets written.
Oh, interesting.
Oftentimes it's left to right as we're reading, and we go, okay, there's a 3, and then multiply in favor of is the pro group, right? So we've stumbled upon the very easy way that a smart person makes that mistake is they're reading sequentially, as we all do, right? As we must, right? And they come across, the words that fit with our symbols in that order, in the order that you would write 3P instead of P equals, right?
I'll start telling my professors that.
Yes, I love that. Yeah, and so, you could do everything right, virtually everything right, and still get 22,500 as your answer.
Yeah.
But if you go back and do the sort of caveman approach,
and just check.
You just check, right? And you go, oh, okay, I'm getting points now.
But that's assuming you have time, so it's important.
Yes. So the ultimate level of this work is being able to build equations, use your answer choices, know this game about the difference between the order of terms sequentially in a sentence, right? And have the experience to move quickly when it counts, right? Which is quite a bit, but we see it done all the time when people are kicking butt. That's what it looks like.
Right.
So, cool. All right. So that was 15. What's the next question you want to look at, Yuan?
16.
16. I love it. Okay. So why don't you read the question for us?
In the figure, lines M and N are parallel. If x equals 6k plus 13 and y equals 8k minus 29, what is the value of z?
One of my favorite friends to talk about math with, when I was showing him some stuff for the SAT, he would call a question like this, he would say that they've nested this question. In other words, like, it looks like it's a question about geometry, and I suppose it is, right? You need to know things about lines.
I thought it was interesting because it's combining concepts.
Yes.
It's like, oh, I'm studying geometry and then algebra.
Yes.
This is combining the two.
Totally.
So it could freak people out at first sight. But...
Exactly. Yeah, so walk us through, how do you approach a question like this? What are some things that you need to know geometrically that are important here?
The angles of intersecting lines.
Yes. Good. Yeah. And I think no matter if they're sort of side by side or up and down, I think it's called vertical angles, maybe the term.
I'm not sure.
I think it is. But like whatever, oh, do not ask what is it, let us go and take our visit, as T.S. Eliot said. We know that X and Y are the same. Let's just like imagine, some of our students are going to be like, okay, hey, I kind of remember that. But if they get that sinking feeling of like, yeah, I don't really know why, but I feel stupid asking, right?
Mm-hmm.
Those are moments when I think it's really important for us to always be like so empathetic. And because we all know what it feels like to feel stupid while people are moving quickly. And what I'll say to people is like, a straight line's 180. And I'll describe that as like, if you snowboard or if you skateboard or if you watch the Olympics or something, when someone turns, you actually kind of know that a full turn is a 360, right? And 180 is half of that, right? So then you'll just say something like, okay, well, pretend for a second that X is 100, right? If there's a straight line, then the one next to X is 80. Right. And then that 80 is part of, what they're calling line T, right? So we could easily get there to know that X and Y are the same, right? That those angles are the same. Yeah. Once we know that they're the same, what do we do with that information?
Well, then you have to go back to the equations they give you.
Yes.
And just set them equal to each other.
Exactly, right? And people get very intimidated when there's all these letters floating around.
And now you're in the algebra section of the question.
Yeah, exactly. Yeah, which is the land of letters, right? In mathematics. But I have some kids that, in the comfort of just a one-on-one session will just say, God, I hate when there's all those letters. Right. And that's okay. Like, it's totally okay to have that feeling. Just be prepared for the fact that, like, you don't have to know everything about the question. Just take the next step. Mm-hmm. Okay. So we would set those equal to each other, right? If X and Y are the same, then 6K plus 13 equals 8K minus 29. Okay, cool. So let's just take a couple steps here. I'll add 29 to both sides, and I'll subtract 6K from both sides. I'm doing those at one time so that we can move quickly, but I would urge people to be cautious about that. 42 on the left.
Yep.
And 2K, so K is 21.
Exactly.
So there's an answer choice waiting for us should we get impatient, right? So I call that the Eureka mistake. What do you think I mean by Eureka mistake?
Well, you get a value that's the same as one of the options. So you're like, it has to be that option.
Totally. Yeah. And indeed, it does not have to be that option. And indeed, it isn't that option. So K is 21.
You have to remember what the question is asking you.
Yes.
It's not asking you what K equals.
Yes. Very good.
So you can actually eliminate, well, not totally eliminate, but it's probably not B.
Yes, it's probably not B. Not only that, but, look, it says figures not drawn to scale. Mm-hmm. Okay, I'm here to tell everybody that, like, if it says that, you should be careful. But also, they're not such jerks that an angle that looks to be acute is going to be obtuse. Okay, mm-hmm. Like, I haven't seen that happen yet. Let's just say they haven't been that kind of jerk in the 20 years that I've been looking at the material. If they're evolving into a new level of jerkery, then we apologize. But if I were moving quickly here, I would say it's almost certainly C. Now, what is the relationship between C and D?
D is the obtuse angle corresponding to Z.
Perfect.
So it'd actually be the value of X and Y.
Yes, which is another Eureka mistake, right? So you solve for X, you solve for Y. So we could certainly check. I mean, and by the way, as soon as we've checked, then what's up with X, then, which is probably the next step either way, mm-hmm. right? We don't have any equation to represent Z.
No, that's back to the geometric side of things.
Yes. Cool. So maybe I'll use 6K plus 13, and I'll say, since we know that K is 21, this is where I know you'll be good about your estimation. Like, we could know precisely what it is, but we could also say 6 times 21 is like basically 120.
Yeah.
Right. So K is more than that, and that means the right answer is certainly C. Right? So there we have it, right?
Yeah.
We see all the mistakes they've built in. I gotta say, I don't really know where 3 comes from. Do you have any theory about that? By the way, on the test, you should not like spend the rest of your time figuring out what the third trap is. Like when you found 2, you're good, right?
I don't actually know.
Yeah, it's kind of weird. I wonder what they're doing there.
Maybe they just got lazy.
Yeah,
just had
it could
to put
be
something there.
It totally could be. Yeah. So fair enough. We found 2 mistakes. We found the right answer, and we've seen the way that geometry and algebra are kind of intersecting on this test.
Yeah.
That was an unintentional pun. What's the next question you want to look at?
19.
19. All right. So now we're getting into the good stuff, right? We're near the end of the test. Just to be clear for students, this PDF document has 27 questions. Yours will have 22. What that means is if you've aced module 1, then number 19 on this document, is probably closer to number 14. Once you get past the halfway point, and even earlier, I've seen as early as like number 7 on module 2, things start to get interesting. They start to get challenging. Okay. So let's start with the last sentence first. So read that last sentence for number 19.
Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane?
Nice. Okay. What do you think about this question? What do you think is challenging or easy to mess up about this question?
I think it just bombards you with so much information.
Totally, yes.
Especially the last sentence, you're transforming it back into the xy plane where you're given a function.
Yes. That's a great point, right? So they're immediately evoking something visual in the context of something that's been provided to you algebraically, right? So that is to say, not a visual graphic representation, right? Yeah. I get this sort of anxiety when I read answer choices that all sound the same. The metaball's minimum height was, the metaball's minimum height was, the metaball's height was, right? That's all. It feels like it will lead me to less clarity the more I read those answers. Yeah. Right.
But you can split those answers into 2. Because one's the ball's minimum height.
Yes.
The other one is the ball's height.
Yes. So the strategy that I call this is, I'm not good at coming up with names. I call this just reading vertically. It's like, what's the difference between the answers?
Yeah.
Right. So min height or minimum height versus just height, right? And then 3 or 7. Basically, that's it. And then if we look down, there's this idea of like above the ground versus when it started moving, right? So those are the differences that we care about.
Yeah.
Okay. So I guess like I almost feel confident I'm almost sure that I can cross off 2 based on that language, just about the idea of a vertex.
Right.
Okay. So see if you can articulate for folks why we might be more confident that it's A or B as opposed to C or D based on the idea of a vertex.
Well, for a quadratic, the vertex is, I guess the simplest way to put it is where the graph changes direction.
I love it. That is a great way of putting it, right?
Which would relate to a minimum.
Yes, exactly. It could either be a minimum or
maximum.
Yeah, and only one happens on any given quadratic function. You either get the low point or a high point.
Yeah, and then if you want to get technical, the x squared here is positive, so it's like a regular u.
Yeah, good.
So it is a minimum.
Good, yeah. And for people who feel like that's just rote knowledge but not like deep knowledge, we can mention to folks that basically after they do some example calculations, that basically the thing in parentheses, which gets squared, always turns out to be a positive value. And then we're multiplying it by another positive value, right? So even if there are some spots in graphs like this that the outcome of the graph is negative, if you put in a huge x value, like a 10,000 or negative a million, right? The outcome's going to be a big positive number.
Yeah.
Right? It's going to get squared. That's going to make it big and positive. So at the, sort of the ends of the graph, I'm not telling you anything that you haven't known for 10 years, but that's like one way that we describe it to people, right?
Yeah.
Okay, cool. So then of answer choices A and B,
Mm-hmm.
based on that fact, what is the trap that you can see between like the 3 and the 7?
Well, one's thinking about the X position of the vertex while the other one's the Y position.
Yes, exactly.
And then you would have to go back to the first sentence, I think.
Yes.
To narrow it down.
Yeah, the first sentence. And I find that this is actually the thing that most of our really smart kids struggle with is that part.
Yeah.
Being like, well, which one's which, right? So this sentence says that it gives the height, f of x in inches, right? So that tells you, if you're careful, that the y value is inches.
Yeah, because at the end it says y equals f of x.
Exactly. And then maybe even if there's any confusion, it says x seconds, right?
Yeah.
So basically, x is the seconds, right? And f of x or y on the graph is the height, right? So I guess the last thing, some student could have put this all in a Desmos. That's wonderful if you need to do it, right? But this is a question where the Desmos person has actually wasted time compared to the person who just knows things about these functions.
Yeah.
So how do you discern between 3 inches as the right answer and 7 inches based on your knowledge of quadratics?
Well, the function's given in this form where x minus 7 squared, it's like a repeated root.
Yes.
So, that's the x position of the vertex.
Yes, exactly.
At 7 seconds.
Yes.
Right.
Yeah. Just rote knowledge would be like, if you know vertex form, then you know that this is vertex form.
Yeah.
The value of x is given in parentheses, and then the value of y is given outside of parentheses, for I should say the value of x and y at the vertex, right? So the vertex is 7, 3, and 3 is the y value. That's the inches, right?
That's the answer.
There we have it. Yeah. Cool. So you can see how, like you said, there's so much information here, but if you move in small stages, then you're able to work your way up to what ends up being the right answer.
Yeah.
So, cool, man. What's the next one you want to look at?
21.
21. All right. Sweet.
This is not multiple choice.
Not multiple choice. Immediately harder, right?
And you can't use Desmos for this.
Tell me why. I think you're right, though.
Because it says in the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b?
Yes.
So you have to know when an equation has no real solution.
Yes, exactly. Yeah, so Desmos itself is insufficient for this question.
Yeah, because it just tells you the solutions itself.
Yes.
But not when certain cases happen.
Yeah, that's great. That's absolutely right. There's something that we can do with knowledge and Desmos, and there's something we can do with just knowledge, right? So which approach do you want to take?
Let's start with just the knowledge approach.
Yes, let's go pure here. Okay, so tell me how you would think about solving for, or I guess not solving, for finding where we can't solve this, where there are no real solutions.
Well, if you're good with quadratics, you know that this only happens when the discriminant is negative.
Yes, very good. So we have to know the quadratic formula, right? Or have it programmed into our calculator. But yeah, knowing the quadratic formula, sometimes I like to tell students about, I like to help students understand why this thing under parentheses is of use to them, right? And so what I'll tell them is, the reason why it's called the discriminant is that's an old-fashioned way of saying discern, right? It has a negative connotation to, be a discriminant person in today's terminology, and rightly so, considering the history. However, 200 years ago, if you had a discriminating mind, that would actually be a compliment, and not for like terrible social reasons, but actually because what it meant is you can discern the difference between things, right? So we could call this the discerner or something, and the reason it's a discerner, and the reason it helps you discern what's going on with the number of solutions, is because of that radical,
Yeah.
Right? So if someone said to you, well, why are there no solutions when the discriminant is less than 0, when it's a negative value? Why is that the case? How would you describe that to somebody?
Because you're taking the root of a negative number.
Yes, because this thing we're calling the discriminant is under a radical. Square root of a negative number is non-real.
Yeah.
Right? And then the reason we can say that there's 2 solutions when it's more than 0 is because of that plus or minus outside.
Yeah.
Right? That gives you 2 different things, right? In my opinion, when we give people like deeper knowledge about this stuff, they have that flexibility to problem solve. Now, if you have like a week before the test, you should not bother about the, etymology of the word discriminant. But it is worth knowing this stuff if you have the time to go deeper, if you're in a 12-week program or something. Okay, so we would use the discriminant, right? And we could let's just set that up for folks. Notice challenges. We won't make people like solve that as they're watching a video or something like that. But so we have b squared minus, and it was b squared minus 4ac.
Yeah.
So tell us what is a here and tell us what is c here.
A would be the integer in front of x squared, so -1.
Yes. And there's no sign there. There's no number there, which will mess with people, right? But it is -1 indeed. And then what is the c term?
-676.
Yes. So one thing that the test makers will do to make this worse on people is they will call this thing, it's actually really nice that they called it B.
Yeah, I just noticed that.
Sometimes they'll call that A or C, which is...
That's pretty mean.
Yeah, that is like, yeah, I take back what I said. They're really mean. They're like high level mean. But yeah, that's something that they'll do all the time. They'll call that A. And then you go to put this into the equation. You have to remember A in our particular function or our particular equation is B in the generalized terms of the quadratic, right? So that's a very devious thing to do. And here we're just solving for when this whole thing is less than 0. So we would solve this and that would be it, right?
Yeah.
So I won't make us actually solve for...
I already solved it. I think
you
it's
did?
more interesting.
What a guy. Okay, let's do it then.
B is less than 52.
Okay, cool. So b squared, basically after we multiply both, -4 times -1 times -676, we maybe add that over, we take the root.
Yeah.
Right? So then you've gotten to b... What was it again? B is what?
Less than 52.
Less than 52.
But 52 is not your answer.
Yes. Very good. Yes. So good point. It's good that we kept going.
Yeah.
Right? Because most people would just do the math and get 52.
And write down 52.
Yes.
But at 52, the discriminant is 0.
Yes.
So, and that is a real solution.
Yes, exactly.
So you have to get, it's a very tricky wording in the question.
Yes.
What is the greatest possible value of b and b, where b is a positive integer?
Yes.
So you just have to go one integer down.
Yes.
51.
And I know I may be exposing myself as a little bit of a dolt, but like the idea that you have to go down when we're talking about what is greatest, even that is like a moment where I get a little bit like, is it 53 or is it 51, right? And it's worthy of your attention to make sure that you understand which way we're going with these. Yeah, very good. So there's always another layer to these questions, and I just epitomize the presumptuousness that leads to mistakes on the test, right?
Right.
So do as I say, not as I do. Do you want to do another one?
Sure.
Do we have time to do another one?
Yeah, you guys are booked. You guys have 2 slots.
Yeah, okay, cool. I forget how long till Mia.
You have until...
I know, I got Mia after you on. Let's see.
2:30 is when
okay.
The next episode ends, but...
Yeah, I have Mia showing up at 1:30, so let's cook through like 2 more questions. Cool.
Sounds good.
All right. So after 21, what do you want to do?
25.
25. Sweet. All right. So we've got 2 circles here. I'll read the question and then you tell me what you notice, right? Okay. I'll start with the last sentence. I just always do that. It's not a huge deal on this question, but which of the following represents circle B. The one thing I would do there is just make sure that I don't forget which one I'm solving for. I've seen like really pernicious questions where it's easy to get confused about which way you should go with a transformation, which is what this question is about, right? So we're solving for B. I'll read the first sentence now. The first two. The equation x squared plus y minus 1 quantity squared equals 49, and it represents circle A. Circle B is obtained by shifting circle A down 2 units in the xy plane. Okay, so tell me what you noticed about this question that makes it of interest to us.
I didn't like their second sentence where it's shifting circle A down by 2 units in the xy plane.
Yes, tell me more.
Down seems ambiguous here, even for me. I don't think this is the best written question.
Yes, but it may be so well written that it's like intentionally.
Because from down you have to go to, it's going down 2 units in the y direction.
Yes, exactly. Yeah,
but maybe that's just my nitpicky engineering brain.
No, but I like that because you're talking about values going down, right? As opposed to visually going down.
Yeah.
Right?
Yeah.
Yeah. That's really, really smart and worth noticing. Yeah. And then, above and beyond that, we could say that, there are some challenges to thinking about shifting down 2 units in the y direction in these answer choices, right? So how do you think about, that work?
Well, we can start with the choices you can eliminate pretty easily.
Yes.
So it's only shifting down in the y direction. There's no change in x.
Yes. So let's get rid of which ones?
A and C.
Yeah, good. Now, by the way, I just think generally it's a good move to say, if you're going to be disciplined about this work, get rid of the worst answers and then think about what remains so that you can be cognizant of what the test makers are doing and not just what you think is right.
Yeah.
Okay. So I think this was a good move, even if you felt like you knew the right answer at first glance. Okay. So the difference, how would you describe the difference between B and D on whatever level you want to go to?
It's just the direction you're shifting it in.
Yes. Yes.
And then with that, it gets confusing because with the circle form, the signs inside the parentheses are in the opposite direction of where you're shifting. Yes.
Yeah. Very good. So sometimes I'll remind students just like a simple phrase, parentheses are a pain. Okay. If you get confused about that stuff and you just remember parentheses are a pain, usually the difference between what shows up in parentheses in an equation and what that tells you about the graph are kind of in opposite directions.
Right.
Right. So that would mean that if we want to shift this thing down 2 units in the y position, down 2 units, then what would happen to the value in the parentheses?
You would shift up or +2.
Yeah, +2. Yeah. Yeah, and you can't quit the engineering brain. It's got to be +2. Yeah, +2, which gets us to answer choice D, right? And that is very counterintuitive.
Yeah.
Right? This is where if you're feeling shaky and you've got time, Desmos is your friend, right? You could literally just take the original equation and you could just make the adjustments. It's not like you have to like do a big thing to just in the bar change the -1 to a -3 or a +1 and just see what happens, right?
Yeah.
So absolutely you can get this question if you're shaky with Desmos, but as you've said before, that's kind of a time penalty, right? It's better to be able to reason your way there.
Right.
Right. Yeah, really cool. So parentheses are a pain. That's kind of the easy lesson to take away from 25. What else?
Back to question 22.
Cool. Let's see. Question 22. Okay, so we've got a graph of a couple equations here. I'll read it, and you can tell me what you noticed that brought this question to your attention here. In this case, it's all one big sentence. If a new graph of 3 linear equations is created using the system of equations shown and the equation x plus 4y equals -16, how many solutions will the resulting system of 3 equations have? Okay, so what What strikes you here?
Well, first it mentions 3 linear equations, but then the graph only gives you 2.
Yes.
So they're hinting at you to graph the third one.
Yes. Yeah. Now, I also think that there's like this thing here, which is knowing what it means for there to be a solution. Okay.
Yeah.
Right. So I've seen people say, well, any intersection is a solution, which is true for a system of two
equations. Yeah.
Yeah. But for a system of, in this case, 3, it would mean that they all intersect
at the same point.
Yeah, at the exact same point, right? So there's actually an easier way of doing this question than like, well, before I tell us what that easier way is, let's also notice that every American kid works with the slope-intercept form.
Yeah.
And we don't even have the slope-intercept form.
That's right.
And you can't just go to Desmos here because you don't have the equations for the other 2. So, I mean, you could, but then you need equations for 2.
Well, you would have to make your own equations.
Yes, exactly. Which
time penalty.
Yeah, huge time penalty there, right? So we're not doing that. So if you actually graph this, most students have to take the equation that's given, turn it into slope-intercept form, and then graph it, right?
Yeah.
And this isn't on paper, so it's not even like they can take this and just draw a new line on the page, right? So there's so many problems with that. But like we already know, based on what we've talked about, that there are only 2 answer choices that are even possible for a system of 3 linear equations. The numbers of solutions that are possible are what?
Either none or just 1.
Yeah, none or 1. Right? So we cross off the answers that don't make any sense. It's not possible for a system of 3 linear equations to intersect twice or infinite times. Okay. So we only have the option of 0 or 1. And we know precisely
where it happens.
Yeah. What are the coordinates there?
8, 2.
Yes, good. And no matter how much work I do here, I could mix up X and Y. So I was very intentionally being like, right, X is 8, right? I'm making sure of that, right? So then if we're going to have 8, 2 as a solution, what can I do with 8, 2 in the given information?
You could simply plug in those values into the equation they give you and see if it's valid.
Yeah, right. And actually, based on all the work we've done together, I know that you would probably not even finish the calculation before recognizing that it doesn't work. Right?
Because you have 2 positive values.
Yeah.
Another side's negative.
Yeah. So
there's no way.
Not happening, right? So that's the opposite of a time penalty, right?
Yeah.
Learning how to use the answer choices and use the points given. So I think I said this to you last time we did this, but like if you give me a table and an equation, or if you give me a graph and an equation, the likelihood is I'm taking the points given from the graph or table and putting them into the equation before I think of anything else.
Yeah.
Right? So yeah, we could have built an equation here, but that would be a time penalty, right? Cool. All right, Yan, let's do one more question. What do you want to do?
17?
17?
Yeah.
Cool. Great. So read the question for me.
In the given equation, P is a constant. The equation has no solution. What is the value of P? And then here the equation is actually just linear. It's not even, because I feel like students, when they see no solution, they're like, it's probably quadratic.
Totally.
But then they see it's not, and then they don't know what to do.
Totally. Yes, that's exactly right. And I almost, in my mind's eye, put a squared exponent of 2 after the first x term, right?
Yeah.
Yeah. So the idea of not knowing what to do with that, you're dead on, because we are told to solve equations. We're not told to find the spots where the equation can't be solved, right? So we are solving for P in as much as P allows us to not solve for a value for X.
Yeah.
Yeah. So how would you think through that?
Well, how it's an integer, like what does the left side have to be for it not to ever be able to equal 84?
Yeah, that's a crazy, that's a sentence we have to ask all the time. Like, what is that even, like, how would that work, right?
Yeah.
Now, granted, though there'd be a time penalty, you could just tell somebody, if this freaks you out, just start trying the numbers, right?
Mm-hmm.
So you could literally say, well, what if P is 0? Wouldn't that be convenient, right? But if P were 0, then let's walk through some implications. If P is 0, then of course 0 times 21 is 0, times X is whatever X is 0.
Yeah, but then you're left with negative 3x.
Yes, negative 3x equals 84, and indeed
has solutions.
Has a solution. Yeah, good. So 0 doesn't work. And then maybe the next reasonable thing to do is say, I want to avoid integers or avoid fractions and go to 4, right? And if P is 4, we've got negative 3x plus 21 times 4 is 84. X, and this at some point is going to equal 84. You could add those together and get 81x equals 84. We don't care what the solution is. We just care that there is one. Of course, if you're confused, you go and find the solution and say, verified, there is a solution. So this is not the value of P I want. So you could just keep going like this, right? But let's see if we can uncover for people how to think about this in a more sophisticated way. So do you have some sense of like how you might solve for P without, using the answer choices here?
Well, if you somehow got the x's to cancel out, the x would vanish.
Perfect.
And then your left side would be 0. Yes. And your right side would be 84, which is not a valid relation.
Yes. Yeah, exactly. So if you could figure out a way to get that to cancel. Now, a good way of thinking about that is maybe factoring. Right?
Yeah.
We could pull an x out of both of the terms on the left, right? So that would give you what? Negative 3 plus 21 P.
Yeah.
And that's all times x equals 84, right?
Mm-hmm.
And now, how would you think about that? If I'm saying I've got this factor, negative 3 plus 21p times x equals 84. How would you think about using that factor?
Well, you're trying to get x to be multiplied by something that's 0.
Yes.
So you set that factor equal to 0.
Exactly.
To find p.
And a lot of kids are just used to that generally, that like factors have to do with like things equaling 0.
Yeah.
Right. Yeah. And at this point, it wouldn't be the worst thing if you could take a glance at the answer choices and you may see 1/7, as a value that rings a bell when dealing with these other values like 3 and 21.
Yeah.
And indeed, when you solve for P, I think that's going to be
fun. I mean, if we continue with our brute force method, once you plugged in 1/7, it would be pretty obvious that that's the solution.
Yeah, yeah. And if you felt like being elegant, you could say, well, 21p minus 3 equals 0. And we could just traditionally solve that. Add 3 divided by 21, p is 1/7, right? Yeah, really good. So this idea of no solutions like really baffles people in linear settings. Sometimes I'll just talk about slopes, right? So I'll say, well, I'll break this one equation into 2 equations, which feels like I'm, adding an extra layer of complexity, but this happens on the test in other places, okay? So we'll say something like, okay, there's a line y equals negative 3x plus 21px, and there's another line y equals 84. And you'll say, what's the slope of y equals 84? And people will blink at you like, because you've asked a silly question, right? So let me ask that silly question. What is the slope of y equals 84?
Well, that's just the horizontal line.
Yes.
So it's 0.
Yeah, slope is 0. So basically, if you ask that question, you can get a person who I forgot to write an x in here. Negative 3x plus 21px has to also have a slope of 0. And you can think about what that means, right?
Yeah.
Yeah. Cool. All right. So this was another set of questions from practice test 4. And we're going to be doing this a lot, but we're also doing this in an SAT lab. So if you want to join us, join the mastery program. Every night after dinner, we're working on math questions. If that sounds like fun to you, then you know where to hang out. Thanks for hanging out, Yan. And we'll see you guys
I'll be
soon.
in those help rooms.
Yeah. Sat Lab coming at you. See ya.